Hi everyone. Last video of the lesson, this is about infinite geometric series. So if you remember when we were talking about series, I told you it was a series because it had a starting point and an ending point. Sometimes we have infinite geometric series that we can find the sums of. The reason why we can find the sums of infinite geometric series, which just go on forever, is because there's only specific ones that you can do that with, but those specific ones, your R has to be between -1 and +1. And when your R is between -1 and +1, that means that your series is getting smaller and smaller and smaller and smaller. Now, it's never going to end up hitting 0, but it will get so close to 0 that we can potentially add all of our answers up together and find the sum of it. If your R was bigger than 1 or less than -1, then it continues to get bigger, or more negative, which then means that we can't actually find the sum of it because it's just going to go on forever and ever and ever. Whereas when it's in between that -1 and +1, because it's getting closer and closer to 0, we can find the sum. So that's going to be a really important part here when we figure this out. If our R is less than -1 or bigger than -1, we're just going to say no sum, it doesn't work. Okay, let's start with some examples. Oh, and let me tell you, this formula up at the top, this S sub n is equal to A sub 1 over 1 minus R, is the formula that we use for infinite geometric series. So our first example tells us that A sub 1 is equal to -3 and R is equal to -2/5. So the first thing I'm going to check is R. Is R between -1 and 1? Yeah, it is. So we're good. We're going to be able to use that formula, which is A sub 1. Okay, so that's -3 divided by 1 minus my R, which is -2/5. Okay, I'm going to plug that into a calculator, which gives me 15/7. And so what that tells me is if I added up all of those numbers all the way to infinity, because those numbers are getting really, really close to 0, we know that it's going to kind of stop at some point, which means that our sum of all of those numbers would give me 15/7. Okay, now let's do the next example. And the next example is 1 plus 2 plus 4 plus 8, We have our A sub 1, but now we need to find our R. To find our R, we're figuring out what we multiply by every time. So to go from 1 to 2, we multiply by 2. 2 to 4, we multiply by 2. 4 to 8, we multiply by 2. So our R is equal to 2. Okay, now remember, our R has to be between -1 and +1 or else it won't work. Well, our R is 2 in this case, which means that it won't work. And because it won't work, we're going to just say no sum. We could potentially plug it into the formula and get an answer, but the answer would be incorrect because your R, in order for that formula to work, your R has to be between -1 and +1. This means when your R is greater, like we said, that just means that it'll go to infinity. If we tried to add all of those numbers up together, you would get infinity. Okay, let's do the third example. The third example is a sigma. So k is equal to 1 to infinity of -4 1/2 to the power of k minus 1. Now, if you remember from the last video, we had a little trick. The number in front of the parentheses is your A sub 1, and the number inside the parentheses is your R. So we actually already have everything that we need to use that formula. And let's just make sure that we can use the formula. The R is 1/2, which means it's between -1 and +1. So we're good there. We can use the formula. And remember, the formula is S sub n is equal to A sub 1 over 1 minus R. So when I plug everything in, I'm going to get -4 on top for your A sub 1 over 1 minus 1/2, which gives me -8. So that is my sum. All right, let's do the very last example, which is another sigma notation. R equals 1 to infinity, 2 times 0.23 to the power of R minus 1. We're going to use that trick again. So that first number outside of the parentheses is A sub 1. Inside is your R. We're going to check the R is between -1 and +1. Yes, it is. And so that means that we can use the formula, which once again is S sub n is equal to A sub 1 over 1 minus R. Our A sub 1 is 2 over 1 minus our R, which is 0.23, which gives me 200 over 77, which is my sum for this one. There we have it, how to solve for infinite geometric sums.